Exercise 5H, inverses. Today we are learning about the relationship between exponentials and logarithms, and by the end of the lesson you should be able to find the domain of the inverse function and also find the inverse function by rearranging a rule. So inverse operations are opposite operations. We've already seen this relationship between exponentials and logs. So for example, we have our rule a to the power of y is equal to x. How would I be able to take the a to the other side or the opposite? Well, I can take the log of both sides. So that's log a to the power of y is equal to log ax. And we also know that log a is just equal to 1. So the y comes down and we get log ax. So that's what we mean by bringing the a over to the other side. When we want to bring it, we'll take the log of both sides and that would essentially cancel out that base. So that's why they're inverses of each other, just like plus and minus are inverses and times and divide. Another example that they've got here in the notes, squaring and taking the square roots are also inverse operations. So that's what we mean by all of these plus, minus, divide, and times. They are inverse operations. The equations of the inverse functions y equals e to the power of x can be found by interchanging x and y so that y is equal to ex becomes x is equal to ey. There is nothing new here in terms of inverses compared to what we've done previously. All you have to do is swap the x and the y, and then you would need to rearrange to get y by itself. And in order to rearrange, you need to use this concept here between a to the power of y is equal to x. Well, y would equal to log ax. So example 20, find the inverse of this particular function and state the domain and the range. We want to do it without the use of technology, so by hand, and then also using the CAS calculator. So make sure you have your CAS with you to practice. So without using technology, what we want to do is swap the x and y. So our original function is y is equal to e to the power of 3ex plus 1. And now what I want to do to find the inverse is swap the x and y. Now I want to get y by itself, so I'm going to take the 1 over and then divide by 3. So that'll be e to the power of y. And then the way to get the e to the other side is to take the log e of both sides, which cancels out that e. So we'll get log e of x minus 1 on 3 is equal to y. In order to find the domain and range, well, this particular function here is an exponential. Just looks like this. It's got an asymptote at 1, so that's x equals 1. So the domain, as you can see, is just equal to r, and we can also see that within our rule here. However, the range, we'll write that properly as x is an element of r. The range, though, is going to be from 1 to infinity. So this is for our original function, or our function f of x. So for f inverse of x, so the inverse function is just going to be the opposite. So now the domain is going to be 1 to infinity, and the range is going to be r. In order to use this on a CAS calculator, what we can do is write it as x is equal to 3e to the power of y plus 1, and then use our solve function in order to be able to find y. So we'll give that a shot now on our CAS. We will add a calculator page and we'll go to menu, algebra, solve, and remember we've swapped the x's and the y, so that'll be x equals, and we'll find the function 3e to the power of y. In this case I don't have a y, I'm just going to write n for now, a, and then that'll be plus 1. And this time I want to solve for y, which in this case I've just got as a for my convenience. And you can see that a, y, is equal to ln, which is the natural log, that's log e, of x minus 1 on 3. And they just specifically tell me about my domain as well, which is that x has to be greater than 1. So you get the exact same answer. It did say ln. You can write it as ln if you like, or of course you can change it to be log e. It's the exact same thing. And it gives you the domain, which is very nice as well. So that's example 20. We're now going to do a very similar thing to example 21. You might want to give this video a pause and give it a shot yourself. So again, find the inverse of the function 2 log 10 x minus 1 plus 1 and state the domain and the range of the inverse function. So without the use of technology, we're going to do the exact same thing where we're going to swap the x and the y. So that'll be x equals 2 log 10 y minus 1 plus 1. And now we want to rearrange to get the y by itself. So first thing is I'm going to take the 1 over, and then I'm going to divide by 2. And then to take the 10 over, I'm going to use my rule, my property, that the base of the log will become the base of the exponential. So that will be to the power of x minus 1 on 2. That'll be y minus 1. And finally, I'm going to take the 1 over. So that'll be 10 to the power of x minus 1 on 2 plus 1. And that's what is going to be equal to y. In terms of my domain and range, it's just the opposite of my initial function. So again, if I give this a quick sketch, it's going to have an asymptote at x is equal to 1, and there's no reflection, so it's just going to look like this. That's why my initial domain is 1 to infinity, and we can also see that the range is r. So for my new function, for the f inverse, my domain is now going to be the range of the original, so that's going to now be r, and the range is going to be the domain of the original, which is 1 to infinity. To do this using the CAS calculator, we're going to do the exact same thing that we did before. So we're going to go to Algebra menu, Solve, and then we're going to write x equals, and we'll put the function in. So that'll be 2 log 10 of x minus 1. Oh, not x, actually, we're going to be using y, but in this case, again, I'll just use a. So a minus 1, and then we also had a plus 1 on the outside. Just be careful with your use of brackets here. Plus 1. And we are going to be solving for y, which in this case is a. So there you can see that a is equal to 10 to the power of x on 2 plus a half, which is our x plus 1 on 2, and then we've got a plus 1 on the side as well. It does look a little bit different compared to what we had initially, so I'll write down what the calculator gives us, and I'll just explain why it looks a little bit different to what we got. So that's 10 x on 2 plus a half on 10, and then plus 1. So what you have to think of is, I mean, there's no reason why the CAS has given it that way. It does make it look a lot more complicated, which is why I prefer to just solve it by hand. But what you have to think of is here, that's 10 to the power of 1 at the bottom, and with our exponential laws, a to the power of m divided by a to the power of n, what you do is you subtract the powers. So all that's happened there is we're going to have x, 10 to the power of x on 2 plus a half, and then minus 1, which is that bottom power. Now minus 1, a half minus 1 is negative a half. So you can see that that's where what we have over here. So if I just split that up, that's x on 2 minus a half. So it is the exact same thing, but it just looks a lot more messy. But that's why, again, I would always suggest to just do this by hand, because sometimes the calculator gives you a weird answer. But overall, that's the end of exercise 5H.